Hello and welcome to the IoT Projects. In this video, you will learn to make a dual-axis solar tracker device using a Arduino in step-by-step manner. In this project, we are going to use some light-sensitive sensor like LDR to track the sunlight and direct the solar panel towards the areas that increases its efficiency. I have divided the video segments into different parts. You can see in the required components are as follows: one mini breadboard, one Arduino Uno, two micro servo SG90 model, four LDR sensor, four resistors of value 10 kilo ohm, two potentiometer. You can download the 3D body design files from the description below. Here, LDR works as a light detector. It is also known as a photoresistor. Actually, it is the light sensitive device as shown in the graph. The resistance decreases as the light falls on it. In this project, we are using 4 LDRs to detect the sunlight, and when they send the signal to the Arduino, it will guide 2 servo motors to better place the solar panel so it maximizes its efficiency. Here we will show you the complete overview of the project. Later on we will discuss about its wiring system, but now we will simulate this project. As we power on the Arduino, all the sensors and servo motors are into the action. You can see in this video. As we increase the light intensity on the LDR sensor, the signal is sent to the Arduino, and hence it guides the two servo motors to better place the solar panels and increases its efficiency. You can see here, as we increase or decrease the light intensity, the two servo motors are into their actions. Using these two potentiometer, you can control the speed of servo motors as well. We will talk about it later on programming section. Connect 5V pin from the Arduino to the lower horizontal row of the breadboard. Similarly, connect the GND pin from the Arduino to the second lower horizontal row of the breadboard. Extend the 5V and GND to the upper horizontal rows of the breadboard respectively. Now connect the power pins of the both servo motors to the 5V. Similarly, connect the GND pin of the both servo motors to the ground pin. Now connect the signal pin of the vertical servo motors to the digital pin number 10 of the Arduino and the pin number 9 to the Arduino horizontal servo motors signal pin. Connect one terminal of both potentiometer to the ground. Again connect the other end terminal of both potentiometer to the VCC, that is 5V. Connect all the LDRs one terminal to the 5V and other terminal of all the LDRs through the 10 kilo ohm resistor. Pin of the potentiometer 1 is connected to the analog pin number A4 of the Arduino board, and similarly the wiper pin of another potentiometer is connected to A5 pin. Now ground all the resistors in pins through the jumper wire and connect bottom left LDR voltage divider pin to the A1 pin of the Arduino. Now connect the top left LDR voltage divider point to the A0 pin. Similarly, top right LDR VDP pin, that is voltage divider point to A2, and finally bottom right LDR voltage divider point to A3 pin of Arduino board. Now we have done the connection. Let's program the Arduino board according to our needs. Here we have the include section for including the servo.h header file that include the servo motor library file. The configuration for horizontal servo is as follows. The servo horizontal is set to the angle 180 degree, and servo horizontal limit when high input is set to 175 degrees, and similarly servo horizontal limit when the signal is low is set to 5 degree. So you cannot change these values depending on your design. Here we have servo configuration for vertical servo as well. But for vertical we have set the degree to the 45 degree, and the upper limit is set to 60 degree, and similarly lower limit is set to 1 degree. In this section we have LDR pin connection. LDR LT is for top left, and LDR RT is for top right, and similarly LDR LD is for down left, and LDR RD is for down right. So on void setup we have attached the vertical and horizontal servo signal pin, and set the servo rotation for horizontal to 180 degree, and similarly the vertical servo is set to 45 degree. We have also set the delay of 2.5 seconds. Now in loop function we have to read the value from the analog pin of Arduino that are connected to LDRs, and calculate the average vertical and horizontal values. On the if and if else statements is used to loop the program and calculate the average values of respective LDRs, and change the degree of servo motors so that it can be more effective. So at last we have added the delay of dt time, you can see in the above program. Now compile the program and upload to Now we need to print the body parts. I have provided all the files in the description below. You can download and print it from there. After printing you will see our final products like this. Now we have to connect all these body parts. So you can see these videos how to set servo motors to their respective place and screw all the components. So this was the tutorial, guys. If you like this video helpful for your project, please subscribe to these channels and don't forget to share our videos on social media. Help us to go more, and I will be uploading more interesting and exciting videos on coming days, so please don't forget to subscribe. Thank you.